Assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. Find the third quartile, Q3, which is the IQ score separating the top 25% from the others. Round to one decimal place if needed. In this case, we do the work in reverse. So we start out looking at the Z distribution, the standard normal distribution, which has a mean of 0 and a standard deviation of 1. I'm only going to look at the positive side because that's really all we need to look at since we're finding the third quartile. Now if we compare this to X, which is the distribution that our random variable was selected from, the mean is 100. So that would actually go in the exact same location. Then we would have 115. Then we would have 130. And then we would have 140. So this is the comparison. It's a normal distribution. The distribution from which our random variable X is selected from has a mean of 100 and a standard deviation of 15. But before we would convert that random variable X to a Z-score in order to then find the area associated with that Z-score. The table would give us the area to the left of that Z-score. Our calculator can give us areas to the left or right depending on how we enter the information into the calculator. So now we're doing this in reverse. So we don't really know exactly what this number is and where this lies. We're not 100% sure. So I'm going to go ahead and erase this information that I just wrote down because technically we don't know where it goes. Well, I could have kept those at the bottom. That's fine. I'll do that. We'll keep those at the bottom. Well, I won't put anything on there yet. All right. But we want the third quartile, which separates the bottom 75% from the upper 25%. So we'll put that here. We don't know if that's exactly where it goes. This is just a rough sketch. So the area of the shaded region here is 25%, or 0.2500. The area to the left of that shaded region, if you're using the table, it's important to always find the area to the left. 0.7500. What you do on the table now, if you're going to use the table, is look within the table at the 4-digit numbers. Those are all areas to the left of some Z-score. And find 0.7500. If you can't find 0.7500 exactly, you're going to use the number that's closest to it. So if you do that, you're looking for the Z-score such that the area to the left is approximately 0.7500. The closest one you'll find is 0.67. So what you just did is you found the Z-score such that the area to the left of that Z-score is 0.7500. Now we need to go and figure out, all right, what is the random variable X associated with that Z-score, or that would produce that Z-score. Before we do that, though, there's a function on your calculator that will do this for you. It's called inverse norm. So inverse norm, and then all you do is you type in the area to the left. And if you just do that, it's going to assume that you're using the standard normal distribution. You could also add to it, if you wanted to, the mean and the standard deviation. but you could just type in inverse norm 0.75. And that's only if you're working within the standard normal distribution. So let's go second, vars. So it's number 3 on our list. You can see these are the ones most often used. So first number you put in is area to the left, 0.75. Always area to the left. Notice 25% was the number in the question, but that's not the number we use because 25% is the area to the right. So 75% is the area to the left. The mean is 0, standard deviation is 1. Paste that in there, and we get 0.67. So this is giving you a z-score, so round this to 2 decimal places. So it equals 0.67. Next, we use our formula. And now we know, out of those 4 variables, we know 3 out of the 4. We know the z, 0.67. We don't know x. We know mu, and we know sigma. All right, those were in the problem. All right, we use a little bit of algebra to solve this problem. So we multiply by 15. That'll cancel that out. We get 10.05 equals x minus 100. We add 100. And then we get 110.05 equals x, and they wanted it rounded to 1 decimal place. So 110.1. So an IQ score of 110.1 is the IQ score such that 75% of all IQ scores are below it and 25% are above it. Now, this is not a good picture because the z-score should actually be moved over left a little bit. That's why I erased those numbers earlier. Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4 inches. The U.S. Navy requires that fighter pilots have heights between 62 and 78 inches. Find the percentage of men meeting the height requirement. So they want a percentage in this case, so we're going to have to convert to a percentage. And that's once we find our answer as a decimal, we just convert it to a percentage by multiplying by 100 and then round the percentage to 1 decimal place. All right. So we want the probability that x is between 62 and 78. So we need to convert the 62 to a z-score first. And it says population mean is 69.5, standard deviation is 2.4. So we do 62 minus 69.5 over 2.4. We get negative 3.13. We then convert the upper limit of 78 to a z. We get 3.54. So this is the same as saying that the population, find the probability that z is between negative 3.13 and positive 3.54. So it's going to be a big number. All right, we can draw a picture of our scenario here in the z distribution, standard normal distribution. 0 is the mean, 3.54, negative 3.13, and we want the area between. All right, now we're going to go ahead and just use our calculator, normal CDF function. If you were going to use the table, you first need to find the area to the left of 3.54, then find the area to the left of negative 3.13, and then subtract those two numbers. We're going to use normal CDF. So normal CDF, negative 3.13, 3.5401. So we go to our calculator. It's the second one down, negative 3.13 to 3.54 with a mu of 0 and a standard deviation of 1. And we get 0.99892 or 0.9989. So 0.9989. They did say they want the percentage. So to convert this to a percentage, 0.9989 times 100, 99.89%, they wanted it rounded to one decimal place. So 99.9% of the fighter pilots are between those two heights.